All right, so let's talk about DVDs. Okay, so normal DVD vending machine. Have you guys ever used a Redbox?
Yes.
Those are kind of like going out of style a little bit with like Netflix and stuff like that. But Redbox is still kind of a thing. So basically, you put in money or swipe your card or whatever, pick out a movie, and it spits out a DVD, right? So if you hit the button A1, what DVD would come out? The Hunger Sports. Gotta love copywriting, right? So Hunger Sports. Okay. What if you hit C2? The Light Night. And B3? Amazing Insect Man. Okay. All right. So it says each time you push a button and input, you may receive a DVD and output. Okay. So every time you hit a button and input, you may receive a DVD and output. So number 2 says, in the DVD vending machine situation, does every input have an output?
No.
Why not?
Because B1 sold out.
Okay, so B1 is sold out. Okay. So it says each combination of input and output can be expressed as a mapping, written input, arrow, output. For example, B2 goes to the Amazing Insect Man. So write a mapping of of the following inputs. So essentially, guys, nice and easy. This would be, iPad was messing up there. We'd have A1 that goes to Hunger Sports. We would have C2 that goes to the Light Night. And we would have B3 that goes to the Amazing Insect Man. Okay, and when we do a mapping like this is one representation of data. So one of your outcomes is to be able to morph information given to you into multiple representations of data. When we do a mapping like this, it's very easy. We just put all the inputs in one bubble. It's not a very good bubble. Put all the inputs in one bubble. We put all the outputs in another bubble. And we draw arrows from each input to its output. Okay? So nice and easy, just like that. That's a very simple example of a mapping. Okay? All right, so this, we have to go back to number 2, okay? Let me explain something in number 2. So when we are talking about a function in terms of inputs and outputs, an output is not limited to a specific DVD, okay? An output is not limited to a DVD. So for a second, I need you guys to just think about getting nothing as a specific output, okay? Getting nothing is a specific output, okay? You can think about an output more like an outcome. Every time I hit B1, what happens?
Nothing.
It tells you it's sold out, right? So every time you hit B1, it tells you it's sold out. I want you to think about that as an output or an outcome, okay? All right, so thinking about that, let's look at number 4. So it says, right above number 4, it says a function. So this is super important to us. A function is a relation in which each input is paired with exactly one output. Okay, so in a function, every input is paired with exactly one output. Okay, so that being said, I want you to go ahead and do 4, 5, and 6 together with your groups. Okay, 4, 5, and 6 together with your groups. Go ahead. Okay, so a function has every input paired with exactly one output. So compare and contrast the DVD vending machine with a function. Okay, so let's talk about that. Is the DVD vending machine a function? Give me a thumb. Thumbs up for yes, thumb down for no. Is the DVD vending machine a function? Easy for me to say. Oops. Good. I see mostly yeses, a couple no's. Does somebody want to tell me why? Okay, I guess I'll just ask more questions. And what happens every time you hit A1? You get the Hunger Sports out. So if I walk up and I hit A1, I get the Hunger Sports out. Aiden walks up behind me and he's like, oh my gosh, Mr. Craw is literally the coolest person I've ever seen in my life. He's watching the Hunger Sports. I want to watch that too. What should he do? He should hit A1, right? And then somebody else walks up behind him and hits A1. Again, the Hunger Sports is going to come out. Yes, eventually it's going to run out of DVDs, right? But we are assuming that it's not running out of DVDs. So every time I hit A1, the Hunger Sports is coming out. Every time I hit B2, the Amazing Insect Man is coming out, right? So every input, every time I push a button, the same thing happens, right? Every time I hit A1, the same thing happens. Every time I hit A2, the same thing happens. That is a function as long as every input like that has exactly one output, okay? Then we look at question 5. Question 5 says, suppose when pressing button C1 on the vending machine, both the dependables and the light night comes out. So I walk up, I hit C1, I get the dependables out. Aiden walks up behind me, hits C1, and the light night comes out. Now is that a function? No, because that one input of C1 had two different outputs. The first output was the dependables, the second output was the light night. Okay? So that one input had more than one output. That is now not a function. Okay? Does it matter? Okay? Does it matter that every time I hit C2, the light night comes out, and then every time I hit C3, the light night comes out? Does that make it not a function? Is the machine still functioning properly as long as that's happening? It is, right? If I walked up to a Coke machine, okay, and I hit the first button that is a Coke button, and the Coke pops out, and you hit the second button that's a Coke button, and the Coke pops out, that's still functioning properly, right? So it's okay if more than one input shares an output. Okay, it's okay if more than one input shares an output. It's just not okay if one input has two different outputs. Okay, so let me say that again. It's okay if more than one input share an output, but it is not okay if one input has more than one output. Okay, that's going to be important as we move forward. Okay. All right. Another real life example of something that would be a function. What'd you guys come up with? Okay, vending machine, yeah, any kind of pop candy vending machine, yes. Anything else? What about Netflix? Is Netflix a function?
Netflix is a function.
Why do you say that?
Because if you click on Breaking Bad or something, you're gonna watch Breaking Bad. You're not gonna watch something else.
Good. Yeah. Every time I click on a particular show, that particular show comes up, right? That's good. Can somebody give me an example of something that is not a function? Yeah?
A claw machine.
A claw machine. That's good. Right? Every time you hit a claw machine or you put money into a claw machine, the output is not always going to be the same. Sometimes you get a teddy bear. Sometimes you get a dragon. I don't know what else comes out of a claw machine. Sometimes you get nothing because you're not very good at a claw machine. Just saying. Or a gumball machine. Ooh, a gumball machine's a tough one. It depends on if they're all the same color or if they're different colors, right? Because if you have a gumball machine that's multicolored and you put a quarter in and you get a blue gumball out, and then somebody else puts a quarter in and they get a red gumball out, that's not a function, right? But if they're all the same, you would. Yeah. Nice. A tractor or a car or any kind of automobile, right? Every time you push, I don't know if you guys know this yet. Can you guys drive yet? You do, but can you? No, I'm just kidding. So every time you push the gas pedal, the car's going to, well, hopefully, as long as you have a dependable car, the car's going to go. Every time you push on the brake pedal, it's going to stop, right? You have the same output every time you hit the gas or brake pedal. Good. Okay. All right, let's go to page 2. For some reason, mine loaded on the same page, so I'm just going to move page 1 out of the way. Okay. So on these problems, I want to name if it is a function or not, based on what we just talked about, right? And then I want to be able to name the domain and range. Okay? So a function is a function because every time you put an input in, a certain output is going to spit out. Okay? Domain is the collection of all of the input values. Okay? The collection or the set of all the input values, whereas the range is a collection or set of all the output values. Okay? So if you're talking about a specific number in the domain or range, you call it a domain value or a range value. Okay? All right, so let's look at A together. Okay? So on A, does every input have exactly one output? It does, right? 0 has one output. 1 has one output. 2, 3, 4 all have one output, right? So we would say A is yes, a function. Whoa. iPad is like lagging majorly. So yes, it's a function. Okay, when we write domain and range, you have to put it in set notation. So I'm going to draw a really pretty set of braces. And then from there on out, they're going to be squiggles. Okay, so they are, I don't know if you guys probably have this button on your keyboard, but it's the brace is like this. Okay, so those are the braces that you got to put them in. Okay, so mine always just end up being squiggles like that. Okay, just make sure it doesn't look like a 3. All right, so input values. We have an input value of 0, 1, 2, 3, and 4. Okay, so there's my domain. My range, got to put my brace down. Ooh, that's a really ugly one. What is wrong with my... There you go. Okay, my range is a whole bunch of 8s. Okay, the important part about domain and range when you're writing it is that you do not repeat values. So since I have a bunch of 8s, I'm only actually going to write it once. So a single 8 is going to be my range value. Okay, so I say yes, it's a function. I put my domain, which is all of my x values. I put my range, which is all of my y values. Do not repeat domain and range values as you're putting them into the set. Okay? All right, so I'm going to give you guys some time to do B, C, and D together with your groups. Okay, B, C, and D together with your groups. Go ahead. Okay, so on B, is B a function? Okay, what happens when I hit 8? Imagine these are buttons. What happens when I hit 8 here? 0 comes out. What happens when I hit 8 again? 1 comes out, and then 2 comes out, and then 3 comes out. Does the input of 8 have more than one output? Yes, it does. It has actually 5 different outputs, right? 0, 1, 2, 3, and 4. Okay, so we would say no, this is not a function. Okay. The domain is nice and easy, right? It's just 8. Ooh, that's a really ugly one. Oh well. They get uglier on the iPad because my stylus gets stuck and stuff. Okay, the range would be 0, 1, 2, 3, and 4. Okay. Any questions on B? All right, C. Is C a function? Or yeses and nos?
Yes. Yes.
There's actually not. Why did somebody that said no? Why? Good. So this input of 3, you can see this input of 3 right here goes to 2 different outputs. So if I hit 3, 10 comes out. Somebody else hits 3, 11 comes out. So that's why it's not a function. Okay. Domain is 1, 2, and 3. Range is 8, 9, 10, and 11. Okay, so that's the mapping that we were talking about on the front page. Then we go to, so the first 2 were tables, right? C was a mapping. D is a set of ordered pairs. Okay, so is this one a function? So you really just have to look at the x's. I have x values of -2, -1, 0, 1, and 2. Do any of those repeat? They don't repeat, so that would, yes, be a function. Because every one of those inputs has exactly one output. If one of those inputs repeated with a different y value, that's when you know that you have, or that's when you know you do not have a function anymore. Okay, so my domain would be all of those x values, so -2, -1, 0, 1, and 2. My range value would be 5, 8, 6. You don't want to repeat 6, right? So if there's ever a repeating value in the domain or range, you don't write it. And then 7. Okay, can I get a comfort level on if it is a function or not? 3, 2, 1, 0. 3, 2, 1, 0. Good. Can I get a comfort level on domain and range? Good. We're feeling good. All right. Let's look at vertical line test. So anytime you have a function that is graphed, okay? So anytime you have a function that is graphed like this one or like these, there's a quick test you can check. Okay, you can check with. It's called the vertical line test. So let's think about this for a second. What were we looking for? What could not repeat in order for it to be a function? What could not repeat? The input, which is the domain, which is the x or y value. X, right? So we cannot have repeating x values. We can't have multiple points at a single x value. Okay? The x values on a graph, okay, the x values on a graph are these left and right values. So all of the points right here would be x equals 1, right? All of the points right here would be x equals 2. All of these points would be x equals 3. That's why we check with a vertical line. We want to see, do any of these x values repeat? Do any of these x values repeat? Do any of these x values repeat? Okay? There are two different types of graphs that we need to look at, okay? So point graphs that have different kind of points like this, those are called discrete graphs with individual points. Any kind of graph that has a solid line or curve on it is called a continuous graph, okay? So you can check with the vertical line test with discrete graphs or continuous graphs. What you are looking for is, do any of those x values repeat? Do any of my vertical lines hit more than one point? So you can see here on this first one, none of my vertical lines hit multiple points, right? So that's why this one is a function. On the second graph here, you can see that my vertical line hits the graph at 2 spots. Okay, when it hits the graph at 2 spots, that's how you know it is not a function. Okay, so if all of your vertical lines hit exactly 1 point, that means every input has exactly 1 output. That is a function. For the second one, the continuous graph, we can see that our vertical line hits more than 1 point, which makes it not a function. And don't get me wrong, it's not that every discrete graph is a function and every continuous graph is not a function. Okay? Don't try to make that connection because it's not true. So let's go ahead and practice vertical line test. So let's look at 3. So do your vertical lines. So we have a vertical line hits 1 point. Vertical line hits 1 point. Vertical line hits 2 points. When my vertical line hits 2 points, what is that? Not a function. Okay, because my vertical line hit 2 points. All right, let's look at 4. So check with vertical lines. Hits 1 point, 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 hits 1 point. That is, yes, a function. Okay? And guys, for the vertical line test, it only has to happen once. Okay? It only has to happen once for it to not be a function. Just because every point does, or every vertical line doesn't hit 2 points, doesn't mean it's a function. Okay? It only has to happen once that we have a single vertical line that hits 2 points. Then it's the whole thing is not a function anymore. Okay? All right, then we look at 5, another discrete graph. It looks like we have vertical, vertical, hit, 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 hit. That is, yes, a function, right? Every vertical line hits 1 point. And then if we look at number 6, another continuous graph. 1 point, 1 point, 1 point, 1, 1, 1, 1, 1, 1. That is, yes, a function. Okay? Okay. Any questions? Can I get a comfort level on vertical line test? Cool. Okay, good.